Okay, I want to talk about some tricks for using your TI as well as Desmos to get your graphs. So you can see here that this will just graph cotangent as is, and you can see that this expression, which this just has a little bit of an amplitude shift and a vertical shift, is pretty easy to graph, and you can see I draw in the asymptotes as vertical lines so I can see them and I can mark them and I can find the x-intercept that way. And this way won't do exactly, but I can easily kind of guesstimate as I'm testing the points I got via my hand methods. Now with your graphing calculator, TI, it's a little bit more work, but not much. First of all, make sure you're in radians. You're going to go here and you're going to put in 3 plus. Now what I'm going to do is I'm going to do 0.5. Then I'm going to do times, so I'm going to do another set of parentheses, 1 divided by tangent x, that's my cotangent, okay? And so now if there's anything else in the cotangent, that's n parenthesis 1, 2, 3. And then I'm going to graph it. And you'll see it even kind of puts in some of the asymptotes. You can also, a lot of times if it doesn't come up good like the way you like it, go to zoom trig. And that will give you the more standard 2 pi to negative 2 pi look. I also a lot of times will come in and manually set mine, especially if I want the scale to be smaller. So this is set to pi over 2. Maybe I want it to pi over 4 to give myself a little bit better scale if I'm trying to figure something out. The other buttons that are useful on you are, there's two things here. First of all, you want second trace. The trace button itself is useful because just again, like with Desmos, to find where this kind of leveling out is, you'll just need to use the trace button, but you can then use that to go, okay, the point I just figured out manually makes sense with my graph. But if you go to second trace, which is the calc menu, and you use the 0 function, and you click enter up there, and then I'm going to just go down until I'm below the x-axis. Oh, no, come on. There we go. Enter again, and then enter a third time, guess. It will find, right here, you see 2.976, same one that's here on Desmos, it will find the x-intercepts for you, which is a useful trick because that's pretty hard to do. You can do it algebraically, it's just quite the mess. It's not so bad on this one, but on some of the ones with phase shifts and all those, it gets pretty cumbersome. It's a very useful trick. You can also put in a specific value if you wanted to look up. So, hey, value, and I want to know when this is pi over 8. And it's going to give you, now if I put in here one that it's undefined as, so for instance, if I put in 0, it will just give me a blank, and that means it's one of the asymptotes, it's undefined. The other useful is your table. So second window will give you your table menu. And so starting at 0, and like say I want to count up by tenths, and you can even count up by, pi over 2. But you probably want to use something like tenths because it's going to give you decimals no matter what. Okay? And then you're going to go to second graph, which is your table. And then this is just your XY table. So you can see right there, that 0, that's one of your asymptotes. Now, how do you find your next one is at pi, if you remember. So I'm going to go all the way down. I should have let it go farther. This next one is at pi, and you're going to see what's going to happen here. So you'll notice right here, between 3.1 and 3.2 is where our next asymptote is, where our pi is. And you can see this huge shift. I went from -9 all the way down here at the bottom to 11 up here at the top over here. So I went from down here somewhere to up here somewhere. And that was my hint that, oh, that was the asymptote. That's the skip. But because exactly pi is not here, I'm not going to see it. But I can see it in the XY table if I'm looking for the right thing. So hopefully that'll help you find these useful things as you're looking for them. You can, of course, always put in the specific values as you're, looking to figure them out.